Hello. This video explains how to build non-manifold geometry in DesignScript for the purposes of doing perhaps some thermal simulation. So let's go ahead and step through this script and show you how we go about doing it. In this script, I'm going to be building a very simple office building that has 5 zones, a central zone, which I call core zone, and then 4 perimeter zones on each side of the building. So I'm going to turn on the debug mode in DesignScript and step through the script step by step and see how it works. The first thing is to define the dimensions of the building. So it's going to be a 30,000 by 30,000 by 15,000 height. So we go ahead and define those. The perimeter zone on the outside is going to be 5 meters, so 5,000 millimeters. And then the number of floors is going to be 5. We start the script by creating a coordinate system. So we're going to borrow the world coordinate system, but then we move it to the centroid of the building. So we move it by half the building width, half the building length, and half the building height. And there it is in the middle of the building. And since we have it there, we don't need to see it anymore, so we can hide it by setting its visible attribute to false. Then we create a core zone in the center of the building by using the cuboid function, and we specify the width and the length and the height of that cuboid. And then we are going to create the zones. They are going to be segmented at 45 degrees, and you'll see a little bit later how that would work out. But we are going to build them by using points, and then from those points we're going to create curves. And then we are going to use these curves as cross sections to create solids. So let's go ahead and create a series of points around the core zone that will help us define the geometry that we need. So we start with a set of 8 points at the bottom of the building. And then we replicate that again at the top of the building. Again, 4 on the outside and 4 on the inside. And then we use these points to create a B-spline curve of order 1. So it is going to be a made out of straight lines rather than curves. That's the first polygon. That's the second polygon on the north. And the north zone is basically a solid that is lofted from these 2 cross sections. We repeat the same procedure for the south zone. So again, a polygon at the bottom, a polygon at the top, and then a solid. Same for the east zone, and same for the west zone. So now that we have these 5 zones correctly defined, exactly the way we want them, with 45-degree surfaces that separate the zones, we are going to union them all together using the Boolean operation union. But this is where DesignScript becomes useful and interesting, is that we can use non-manifold geometry to Boolean these spaces together. So we set the flag for regular to false, and that creates a non-manifold geometry. A non-manifold geometry will maintain the interior surfaces that segment these zones. If we did not use non-manifold geometry, if we use manifold geometry, we would end up with a simple cube. All of these interior partitions would be lost. The reason we would need them is for thermal simulation, to actually define thermal zones in between. So we start by creating something called building. We're calling this new geometry building, that is made out of a union of the core zone, with the cube in the middle, and the north zone. And then we will add to that, we will union in all the other zones one at a time. So building is again now the union of the core zone and the north zone, and then we add the south zone, then we add the east and the west zones. Now that we have our building, we need to hide all the operands that we used and the points that we used to build this geometry. So I'm going to go through a series of setting all the visible attributes to false of all the geometries that we don't need. We really are interested only in the final geometry, which is called building. So here I'm hiding all the points, as well as the curves that I use to build these solids from. Okay, now that we have this building geometry, we need to segment it horizontally into 5 floors. So that's easily done by creating a series of planes, horizontal planes, that we will use to slice this geometry. So we'll start with a base plane using the plane function, and we will translate it or move it down to 0, 0, 0. So we are going to move it along the Z by half the building height, so it moves down. And now that we have it at the base of the building, we will create a set of floor planes as offsets from that plane. So base plane dot offset with a replication guide allows us to create the remaining planes that we need. So those are now a series of planes that are cutting this. So now we can say to building to slice itself with these floor planes. Again, we are using non-manifold geometry to maintain the interior surfaces. So here we are. We have now the building correctly defined. So now we can go ahead and hide the base plane as well as all the remaining floor planes that we used. And there it is. This is the final geometry. The building now can tell us, since it's a non-manifold geometry, can tell us what cells it has and the volume of these cells. So building.cells gives us back the cells of this building, and building.cells.volume gives us the volume of these cells. So we save that in a variable called cell volume, so that becomes a list. And we can go ahead now and print that to get a series of volumes. And we can click on the output button to see those numbers. So these numbers are in millimeters cubed, and they represent the volume of each of these cells. Thank you for watching.